Hey there, welcome to lesson 5.3, which is about solving systems of equations with elimination, which is a really fun method as well. So our opener that we're going to go over in class today is this: what do they do incorrectly here? I'm going to give you a few seconds to identify, and then you can figure out and we can solve it together. So as we look what they did, the first thing they did is they rearranged one of the equations to be y equals. This one was already a singular y, so that was a good choice, and they did this part correctly. They then plugged that y value into the spot where the other y value was, into the other equation, and they solved it out, and they solved for the x value correctly. So the value of x was 6. But you'll notice as they solve through this one, they get another value of x. So that right away tells you an issue, because we should have an x value and a y value, not an x and an x value. You'll notice here that they should have plugged in the 6 over here, not right here. So that's where we're going to solve it right now. So we would have 3 times 6 plus y equals 9. So this would be 18 plus y is equal to 9. Therefore our y value would be negative 9, because you'd subtract 18 from both sides to get that. Our coordinate point for this one would really be 6, negative 9. You can check the work, you can use graphing, you can use whatever you need to check the work here. Alright, learning target for today: solving systems by elimination. Make sure you write these down. Again, this is a lot to write down for the steps of elimination, but it's important to know what you're doing before you do it. So, write down all these things, and this next example is going to show you exactly what this means. So for now, just write this stuff down. The next step, you're going to see how it works. Alright, so here's an example of one we can use elimination for. And we can use elimination for this because you will notice that you have these two values here, the 3x's are the same, and these two values, 2y and negative 2y, are opposites of each other. So you can choose which way you solve this. I'm going to choose this way. I'm going to add both of these equations together, because positive 2y and negative 2y will naturally cancel out. When you add those two things together, you'll get 0. So you'll get 6x plus 0, so we don't have to write it, is equal to, well, in this case 0, because 4 minus 4 is 0. Then we get the value of x is simply 0. Once we have a single value of x, we can plug it back into either equation. I'm going to use the top equation because it's simpler and there's no negatives. So when I rewrite that top equation, I'm going to get 3 times 0 plus 2 times y is equal to 4. Well, 0 times anything is 0, so it cancels out, so we're left with 2y equals 4, and our y value is simply 2, meaning our final answer here is 0, 2. Other times, when you see these problems, you will not have things naturally cancel out. Notice how negative 10 and 5 would not add together and go away, and 3y and negative 6 would naturally not cancel out. However, both of these can be multiplied so you have opposite numbers. I'm going to take the positive and the negatives and work with those first, because just like the last problem, I find that a little bit easier when you're trying to cancel out these ones. So 3 multiplies into 6, so I'm going to multiply this top line. I'm going to multiply all that by 2. And what that will give me is the following equation set. So if I multiply that one first one by 2, because 3 times 2 is going to be positive 6, I'm going to get negative 20x plus 6y is equal to 2. For good measure, I'm also going to rewrite the second equation underneath it, so it's in line and formed up. And now I'm going to add these entire equations together, because again, as I add positive 6 and negative 6, this will naturally cancel out. So now we're going to be left with negative 25x is equal to 25. Divide both by 25, we get x is equal to 1. Again, this is where we can go back in, we can add it in either equation. In this case, both the equations aren't necessarily clean, so it doesn't matter which one you put it in. I'm going to put it in the top one to start. So our original equation was negative 10x plus 3 times y is equal to 1. So when I plug in 1, I get negative 10 times 1 plus 3y is equal to 1. This is going to be negative 10 plus 3 times y equals 1. And actually, I made a mistake. So back here, you might want to back it up a sec. When you divide both these by negative 1, you should have gotten negative 1 over here. So therefore, we're actually going to be plugging in a negative 1 here, which makes this a positive 10. Alright, so now that we've fixed that mistake, my apologies on that, we would then continue to solve. So we'd subtract the 10 from both sides. We get 3y is equal to negative 9. Divide both by 3, we get y is equal to negative 3. So again, just to make it clear, my mistake I made was right here. I divided both by 25. I should divide it by negative 25 because I want to get rid of this negative. Therefore, it becomes negative 1 here, which is why I plug in a negative 1 over here. My final answer for this is now the coordinate point of negative 1, negative 3. Again, you can double check that work by plugging those values in, or by graphing. You have other ways of checking as well. This here is just a summary of the 4 major types of things you may have to do when it comes to solving systems of equations. The first way was graphing. This was pretty straightforward. The second way was substitution. This is when we took one value of y or x and plugged it into the other equation. Elimination, when it's simple, like the first example today, is going to be where you can just add or subtract them. Elimination, where you have to multiply first, is probably the most common. Sometimes you have to multiply both equations, not just one of them. This is an example where I have to multiply both equations. So, their example is they have a business and buys 7 large vans and 5 small vans. 2 different locations get the 2 different things. So location A has 5 large vans and 2 small vans, and location B has 2 large vans and 3 small vans for their total cost. So that's how they built these equations. Again, each sentence, like location A receives 5 large vans and 2 small vans for a cost of $235,000, is modeled here in this equation, and then it's modeled here in this mathematical equation. So once they've converted it down to a mathematical equation, we're then looking at these ones. Notice how naturally 5 and 2 don't cancel out, 2 and 3 don't cancel out. So we are going to have to modify both of them. In this case, they modified both of them by multiplying them both so they get to the positive and negative for the y values cancel out. You could have also done the x values canceling out. It doesn't matter which one, you just have to pick a direction and go with it. So once they have this new equation, they multiplied everything on the top, so all 3 pieces, by negative 3. Which is why they got negative 15x minus 6y equals negative 705,000. The next one, they multiplied everything by 2, so it's all right here. As they add the equations, as they go through, they're just adding these equations down, so we're left with negative x equals negative 385,000. They solve that out, they get x is 35,000. A big number, but there's a lot of zeros, so it should be easy to work with your calculator. You substitute that 35,000 in for the x value. You resolve for y, you get y is equal to 30,000. So what this means is that the x value is 35,000, the y value is 30,000, remembering that x and y were the costs of each one. So a large van costs 35,000 and a small van costs 30,000. You can plug this in to make sure it makes sense as well. And that's it for today. Good luck on your homework. Like always, if you need help, let me know.